What if Earth stopped spinning? We asked AI, here's what it showed. Everything stops. The oceans rise. The sky falls. The Earth screams. This is not fiction. It's a simulation based on real data. We fed an artificial intelligence system with atmospheric, tectonic, gravitational, and astronomical information to create an extreme, yet scientifically plausible scenario. What would happen if Earth suddenly stopped spinning? This is infinite curiosity, where the impossible becomes a question. What if everything you knew was just the beginning? Earth spins on its axis at over mil miles per hour at the equator. This constant rotation is invisible to us, yet it holds everything together. The climate, the tides, the planet's shape, its balance. Now imagine that rotation halts suddenly. No deceleration, no warning, no explanation. In that instant, everything not anchored to Earth's deep crust would be hurled eastward at uncontrollable speeds. People, cars, planes, buildings, oceans, forests, entire cities. In the United States, cities like Miami, Houston, New Orleans, and Atlanta, low-lying areas, would be among the first to suffer the blow. The atmosphere, still moving due to inertia, would transform into invisible blades traveling at over mil miles per hour. Picture this: New Orleans Superdome flying like a sheet of paper. The Golden Gate Bridge in San Francisco twisting upon itself. In Las Vegas, metal structures ripped away like twigs. And in the Grand Canyon, a landslide of rocks unleashed by massive vibrations would fall like a storm into the abyss. Niagara Falls would stop flowing for seconds, only to briefly reverse, struck by pressure-induced backflows. But this isn't just a local event. Globally, cities like Tokyo, Mumbai, and Mexico City would also feel the force of this sudden stop. Thousands would be flung by inertia. Buildings would collapse. Entire transport systems would be obliterated. Fascinated by the universe's greatest mysteries? Subscribe, comment, and join us as we explore them with the most advanced artificial intelligence. While the ground stops, the atmosphere does not. Air keeps moving, now aimless, chaotic. In AI simulations, we see a phenomenon comparable to over 1,000 simultaneous Category 5 hurricanes. For context, Hurricane Katrina reached winds of 175 miles per hour. Hurricane Andrew, one of the most devastating in modern history, reached 165 miles per hour. What we're seeing now exceeds miles per hour. Structures don't just break, they disintegrate. National parks like Yellowstone and Yosemite would be flattened. Trees turned into airborne spears. In cities like Chicago and St. Louis, skyscrapers would collapse eastward, triggering an unstoppable domino effect. Wildfires would become uncontrollable. At that speed, wind turns a spark into a firestorm. Frictional heat would raise local temperatures high enough to ignite even concrete. Across the world, from Paris to Sydney, devastating winds would level coastal regions, destroying infrastructure. The climate impact would be global, spawning tornadoes and storms on a scale never before recorded. Like the atmosphere, the oceans would retain their inertia. Water would surge violently, slamming into coastlines with catastrophic force. On the U.S. East Coast, from New York to Florida, a wall of water would erase everything in its path. On the West Coast, Seattle, Portland, San Francisco, and Los Angeles would be crushed by mega tsunamis spawned by the ocean's chaotic momentum. The San Andreas Fault, one of the world's most studied, would snap with unprecedented violence. Instead of shifting centimeters per year, it would release millennia of built-up energy in seconds. The resulting earthquake would exceed all known scales. National dams would collapse. Drinking water would mix with waste, triggering a parallel humanitarian crisis. Nuclear power plants, overloaded and without backup systems, could go into meltdown. Globally, countries like Indonesia, the Philippines, and New Zealand would also endure massive tsunamis and simultaneous earthquakes from tectonic chain reactions. With rotation gone, the day-night cycle disappears. One half of the planet falls under perpetual sunlight, the other, eternal night. The dividing line, called the twilight zone, becomes the only temporarily livable area. In the US, Southern California, Arizona, New Mexico, and parts of Texas would remain under constant solar exposure. Temperatures could reach 140 degrees Fahrenheit, scorching the ground and annihilating all unprotected life. Meanwhile, northern states like Montana, North Dakota, Minnesota, and Michigan would fall into absolute darkness. Temperatures would plummet below -100 degrees Fahrenheit, freezing even carbon dioxide in the air. In Europe, places like southern Spain and southern Italy would endure unbearable heat and extreme droughts, while Scandinavia would plunge into an unending winter. In Asia, the Gobi Desert would become a furnace, while Siberia would freeze in eternal night, paralyzing millions. Fascinated by the universe's greatest mysteries? Subscribe, comment, and join us as we explore them with the most advanced artificial intelligence. This might seem unreal, but Earth has changed before. In 2010, the 8.8 magnitude Chile earthquake shifted Earth's axis by 3 inches. In 2011, Japan's 9.0 magnitude quake moved the axis 6.5 inches. Both events shortened Earth's day by milliseconds. Though imperceptible to us, satellites, navigation systems, and global weather recorded the effects. These changes altered ocean currents, affected bird and whale migration patterns, and triggered weather anomalies that scientists still study today. Artificial intelligence used this real-world data as a foundation to simulate a total rotation stop, extrapolating consequences on a scale never imagined. Electric grids, telecommunications, transportation, everything collapses. Satellites become misaligned. Orbits change. The International Space Station loses contact for hours. Global positioning systems, GPS, become unusable. Planes in the air have no way to stabilize. Thousands of flights crash. Ports sink. Roads break apart. The world financial system collapses in seconds. No power, no internet, no banking, only survival. The Earth has stopped spinning, but life still clings on. Amid the chaos, artificial intelligence proposes survival scenarios. Simulations that, although hypothetical, have a solid scientific basis. It's not just about imagining, but designing alternatives that could work if the impossible became reality. First scenario: underground cities. The twilight zones, where the sun barely touches the horizon, become the new refuge. Here, the balance between light and shadow allows a minimal margin for life. AI proposes self-sufficient underground cities. Networks of climate-controlled tunnels powered by geothermal energy. Vertical farming with LED lights. Air purification systems based on space technologies. Cities like Denver, Kathmandu, Cape Town, or Santiago could have access to viable geothermal resources. Here, temporary shelters would be built that transform into stable civilizations. Second scenario: orbital habitats. The planet's halt forces us to look to the sky. Self-sufficient low Earth orbit space stations, spinning to generate artificial gravity. Inspired by projects like the International Space Station or the Stanford Torus concept, these structures could house hundreds or thousands of people. Their advantage: thermal stability, constant solar energy, and distance from catastrophic Earth effects. But they also carry challenges: limited supplies, radiation risk, and prolonged isolation. Life in space is both a promise and a warning. So, could it happen? The answer is yes. Although the probability is infinitesimal, the exercise of imagining it connects us to a deeper truth. We live on a living, dynamic, fragile, and extraordinary planet. We live as if the world were eternal, as if the sky were always blue, as if gravity were unchanging. But all of that is a delicate balance, an invisible dance that surrounds us every second. Artificial intelligence has shown us what happens when that balance breaks. Not as a punishment, not as fantasy, but as a warning. Because every second the Earth spins is a gift. Every sunset, every sunrise, every wave returning to the shore is the result of a cosmic dance we don't control, but on which we depend. And if today we can imagine the unthinkable, maybe tomorrow we can protect the invaluable. This is infinite curiosity. Keep exploring, keep questioning, because sometimes the most impossible questions are the ones that teach us the most. Fascinated by the universe's greatest mysteries? Subscribe, comment, and join us as we explore them with the most advanced artificial intelligence.